Hey folks, let me ask you a question. How comfortable are you in statistics? Whenever you hear the word mean, median, mode, or standard deviation, do you feel excited? Or do these words generate fear in your mind based on your experience in school or college? Well, why I'm asking this question is if we want to learn data analytics, it's of paramount importance that we be comfortable with statistical measures, statistical language. And if you are not good at it, or if you are not comfortable with it, we need to learn how to be comfortable and how to be good, because understanding statistics helps us in understanding analytics and also be good at it. So don't worry if you fall in the category of the people who are not comfortable around statistics. In this video, I'll try to explain the basics of statistics and also help you become good at statistics by following 5 steps. Hi, I am Chaitanya Gondi. I am a data analytics coach and the co-founder of Swachh Data Analytics Hub. I am on a mission to help 1 million working professionals achieve career growth by learning the skills of data analytics. And that's why I want to help you understand, be good at, and have fun with statistics. So here are those 5 steps that will help you on the path to learning more and more of statistics and enjoying along the way. Step number 1 is we need to understand the measures of central tendency. These are the measures that can represent the entire data we are interested in. For example, let's say we are interested in the sales of automobiles of, say, Honda company during 2022, that is from January 2022 to December 2022. Now, from the data that is generated, there are certain values that if we replace the entire data with these values, the picture will not change much. And that's why these measures are called representative measures. And they are also called as measures of central tendency. So what are these? The first is the arithmetic mean, or it's also called average. So we calculate the sales figures in this case, add them all up, understanding that their weights are same. So we are not going into weighted average. And the sum we divide by the total number of values in a very simple understanding of mean. In a subsequent video, we will understand the various methods of calculating mean. So for now, we'll understand that mean is the first statistical measure and one of the most popular ones. Then we have median, which is nothing but the middlemost value. It tells us exactly 50% of values are less than this particular median and the remaining 50 are greater than this. Then there is mode. What is the maximum occurrence or which sales figure is occurring the most number of times? So in some cases, mode may not be the value that is of interest, but in some cases, let's say if I are interested in finding out which car has sold the most, then the mode is the value we are interested in, because that will tell us the car that has the most number of sales. So depending on the situation, one or more of these statistical central tendency measures will be of relevance. So mean, median, mode, understand them, be good at them, practice them using your day-to-day data or maybe data of your company. So this is the number 1 step. Step number 2 is to understand the deviation. Now we've got the measures of central tendency. We need to understand whether the data is spread around these central tendency measures. That is, the most of the values of the data, are they falling nearby these central tendency measures, or is the data spread out? So how do we know that? In the entire data, if we arrange in an order like increasing or decreasing order, we'll come to know what is the maximum value of that particular variable. For example, sales in this case, what is the maximum sales figure? What is the minimum sales figure? These two create the boundary. And between these two boundaries, all the values lie. So the difference between maximum and minimum gives us the range, which is one of the measures of dispersion. However, range is not giving us the total picture because it doesn't tell us how the values are spread around the central tendency measures. So a better picture we can get from variance and its square root standard deviation. In fact, when we understand variance, we'll understand that variance is arrived at by subtracting each data value from the mean or the median, if you are calculating variance with respect to mean or median respectively, and then squaring those values and dividing the sum of the differences with n. We will calculate that, so don't worry about the method. But the point here is that variance has values or units which is equal to square of the unit of median or mean. So definitely a standard deviation, which is the square root of variance and has the same unit as mean or median, will give us a better picture of the dispersion. That's why in statistical language, we often hear the word standard deviation. Then there is one more measure, coefficient of variation, that also helps us understand the deviation, because coefficient of variation is nothing but standard deviation upon mean and then converting it into percentage. Now, step number 2, we have understood how the data is dispersed around the central tendency measures. Step number 3 is nothing but measures of association. If we are studying the sales or the trend of sales of the automobile, in this case Honda car, from January to December 2022, what are the factors that are influencing these sales? Is it the price? Is it the features? Is it the competitors? Is it the economy? So we have data about all these and we compare the trend. So if the trend of sales is increasing, and if that other factor we are trying to verify is also having the similar trend, then we can understand that maybe they are correlated positively. Alternatively, if that other graph is on the opposite trend, we can say, I'm not saying we that immediately will tell us, but we can say the correlation is negative. And if it is totally unrelated, one is increasing and the other is like following a different trend only, we can say they may not be correlated. Now understand, correlation doesn't mean causation. That means it doesn't imply by just understanding the data that that particular factor, let's say price or economy or competitor, is directly influencing this. It may not. There might be an underlying hidden factor. But it only tells us that these two values need to be studied in deeper detail because they are showing some correlation. So measures of association, correlation, then we have another term covariance, and then we have a regression, wherein we try to arrive at the line of best fit, or we try to predict the future values based on this correlation statistics we are getting. This is number 3 step, understanding the measures of association. Once we have understood these 3 steps, we are then comfortable in understanding the shape of the curve. So what is the shape of the curve? When we plot the values in a graphical term, we will have the central tendency measure at the center. Let us say in one case, we have mean and median as the same value and even mode. So the graph, the picture, if we develop, will look like a mountain which is uniformly drawn on both sides of the center peak. That's called a uniform distribution. It may also happen that the mountain may be in such a way that it is tilted to the right or to the left. Why it will be tilted to the right or left? Let us say the central tendency measure, which is the median, the 50% of values are lying lower and 50% are lying higher than the median. However, if we see that when we compare the mean and the median and we find that they are not coinciding, maybe the mean is on the right side of the median or on the left side. Or in other words, we can also say that there are more data values that are lying on the lower side So the graph will now tilt a bit and it will not look uniform. This can also be the opposite. That is, more values can be on the higher side of the central tendency measure. So what we are understanding is the shape is not uniform but skewed, the skewness. So in a subsequent video, we will understand in a deeper detail what is this skewness and what does it imply. Then other measure is that about the shape of the curve. The shape of the curve can rise to be a higher peak or can be a smaller peak. When it will be a higher peak? Generally when most of the values are crowded around the central tendency measure. If most of the values are dispersed, the graph will look like this, as if it has a less peak and spread out. This is called kurtosis. So kurtosis and skewness. So skewness is the shape of the curve around the mean. Okay. Kurtosis is the peak of the curve, whether it is sharp or not. These two determine the shape of the curve and they tell us a very great picture of the data we are interested in. So this is our step number 4. And finally, step number 5 involves two things. One is understanding how can these data measures be represented in visuals in an appealing way. For example, when is the column chart preferable? When is the line graph preferable? When is a pie chart preferable? So understanding these various visuals. Also, understanding the box plot. And what is this box plot? We have understood the central tendency measure, let's say median. Now we will understand measures related to this median, which is nothing but divide the data into 4 equal parts. The first 25% of the data from the lowest value to the first 25%, if we are arranging it in increasing order. So lowest value to 25%. So this is called Q1, first quartile. So first quartile is the point wherein if we are arranging the data in increasing order, 25% of the values are either less than this value or equal to the value. Then we have second quartile Q2. 50% of the values are either less than this or equal to this. And we know that Q2 is nothing but median. Then we have the third quartile Q3, 25% above the median. That is 75% of the values of the data when arranged in increasing order are either below this Q3 or equal to Q3. And then we have the largest value. So now we have how many values? The smallest value of the data, the first quartile, the second quartile or the median, the third quartile, and the highest value. 5 values. And when we represent these 5 values, that plot is called the box plot. And it tells us the entire picture. Because the uniformity of the box plot, let's say the third quartile and the first quartile, these two are enclosing 50% of the data values. And the difference between these two is called the interquartile range. So is Q3 the distance from Q3 to median and the distance from Q1 to median, is it same or is it not same? Correct? Then also the distance between Q2 and the lowest value and the distance between Q2, that is median, and the highest value, are they same or different? This will tell us a great deal about the nature of the data we have in our hand. So friends, the 5 steps to recapitulate: understand the central tendency measures, mean, median, mode; understand the dispersion of the data around the central tendency measures by finding out the range, coefficient of variation, variance, and standard deviation. Then understand the measures of association by understanding and comparing this trend or this particular data with the data of another variable to see whether they are related, that is positive correlation or negative correlation. Maybe covariance and regression also can help in some cases. Step number 4 is to understand the visuals, how to represent the graphs, because visuals help us in understanding the data in a much better way than the tabular form. So which visual is apt? For example, the trend of sales, if you want to know, a line graph is better suited for the purpose. Percentage of one component or percentage of a particular segment with respect to the overall picture, if you are interested in, maybe pie chart. Just give an example. Step number 4 about the visuals. And step number 5, the box plot and each of the 5 measures: smallest value, first quartile, second quartile or median, third quartile, and the largest value. And I've missed one step in this: the shape of the curve, the skewness and the kurtosis. Maybe that was step number 4. So step number 4 was shape of the curve, and step number 5 involved two things: the visuals as well as the box plot. So here you go, friends. Start with these steps, become comfortable at them, use them in your day-to-day data, whatever you have, maybe household data, maybe the data of your organization. So work around these, become comfortable with these 5 different statistical measures, which I have detailed out in 5 steps. And then we are ready for diving deeper into statistics to understand the probability distribution, discrete, maybe binomial, Poisson, hypergeometric, maybe continuous distribution, maybe understanding the estimation of parameters of population based on the sample and what is the sampling error, maybe the Z test, T test, and on and on. And soon enough, we'll find that statistics is not that difficult to learn. Hope you like this video. If you have any thoughts or any of the topics of interest, I would cover them in the subsequent video. And I want you to share in the comments below about what is it that you would like to know. So happy learning and enjoy your day. Bye.